And we'll just get as far as we get, and then we'll pick up on Monday after break and go from there. So what about something like this? Use the given substitution in the chain rule to find dy dx. And you know, probably I wouldn't even necessarily give you that substitution. You could just figure out the substitution on your own. Right, let's just do this. We don't need to cheat and have that. We can just get rid of that.
I like cheating.
So if we've got y equals sine, just all this is peeling the onion, right? Chain rule stuff. So when we're differentiating this guy at the outermost level, what are we going to get? Y prime equals, what's the first layer going to be? Cosine. Good. Derivative of sine hand is cosine hand. Good. And the hand is square root of 10x. Okay, what's the next link in the chain? Square root of 10. Yeah, good. Because then if we look inside, what's inside the function? If I take the square root of the argument of the trig function, it's just times square root of 10.
Yeah.
And then if I were to simplify that, probably the only thing I would do is just pull the constant out front.
Yep.
Square root of 10 times cosine square root of 10x. Good. Okay. That's it. That's it. Right.
No, because you get
Okay. Questions? Okay. That's it. 2 layers. Remember, there's going to be a link for every layer in the chain rule, right? Okay. What about this one? Now this is, it's a little bit nasty, but you can't, I mean, you kind of just got to work your way in. At the outermost level here, from the outside, what is it? Good. It's power rule, isn't it? I've got derivative of hand squared, which is just 2 hand to the 1. Good. So the first layer equals what? 2 times hand to the 1. And hand is just a negative sine x over 1 minus cosine x. So the next link is kind of a big one, isn't it? Yeah, it's quotient rule. When we peel away the power and we look inside, we got a quotient of 2 functions. And so we better give ourselves a little bit of space. I'm just going to block off a big quantity here for the quotient rule stuff. Okay, so what do we get for quotient rule then? Okay, so bottom, good, I heard it, bottom times derivative of top. So 1 minus cosine x times the derivative of negative sine x. What's the derivative of sine x? Cosine x times negative 1. That negative 1, remember, is just a coefficient. Just leave it out front.
Yeah.
So negative cosine x minus times derivative of the bottom.
Yeah.
So what's differentiating the bottom? Derivative of 1 is 0. Derivative of cosine x is negative sine times negative 1 sine x.
Kill them.
All divided by
1 minus cosine x
squared.
Science?
Kill them. Dude, we're rocking this.
Okay, we good?
Yeah.
Okay, so that's pretty messy. Pretty messy. So let's just, well, what are we going to do here? We combine like terms, we could multiply straight across. Let's see, if we, one thing that's helpful is to break this up into a great big fraction, right? Just make it a big rational function. So we're going to have the top stuff and the bottom stuff. So on the top, we've got a 2 times a, let's make it a negative 2 sine x. How about?
Okay.
Everybody see that if I just combine, right? Negative 2 sine x, and then all this junk in here.
Yeah.
So if I, let's see, if I distribute this negative cosine, that's going to give me a cosine squared minus cosine. Everybody see that?
Yes. I can't see that.
Okay. And that's just, once again, that's my own bias for wanting to put the positive terms first. I think eventually it makes things easier. So cosine squared x minus cosine x. And then over here we're going to get minus a minus is plus sine squared.
Yep.
Okay, all
I'm seeing
divided
that
by.
there, yep.
Now look on the bottom what we got here. We've got a 1 minus cosine x, quantity 1 minus cosine x, times the quantity 1 minus cosine x squared.
That's cubed.
So it's cubed. Good, good. So we end up with a 1 minus cosine x quantity cubed. Good, okay. So what to do with that? That looks terrible. But what we're always looking for when we're dealing with these trig functions is, we're looking for some identities that help us out here. Do you see a big
Yeah.
identity?
Cosine and
Okay,
squares and then
good.
sine is squared.
Look at this guy. Cosine squared x plus sine squared x
1.
is just 1, isn't it?
Yes, it is.
That's a good one. So,
So it's me 1 minus cosine.
Yeah.
so we get a minus
That's
2
filthy.
sine x times 1 minus cosine x. Wasn't that convenient?
That is convenient.
Over 1 minus cosine x cubed. Okay, now can I cancel a 1 minus cosine x here?
Yes.
Yes.
I can, can't I? Because it's a factor of the top and the bottom,
Yes, it
right?
is.
I've got 3 factors on the top, negative 2 sine x and 1 minus cosine x. As long as it's being multiplied on the top by everything, if it's a factor, I can cancel. And so we make that a 2, cancel out 1 from the top, right? Make sense?
Yes, it does.
And we got it. Minus 2, that's probably about all we can do, isn't it? Minus
That
2
is what I
sine
see.
x over 1 minus cosine x quantity squared. Make sense?
Yes.
Oh, did we forget something up there though?
We better-
Yeah, I did, didn't I? Oh, no, I didn't. Never mind.
Okay, I was
No,
like, whoa.
no, we're good. Never mind.
Whoa.
Brain fart. Thought I did, but I didn't. Yeah. Questions? No?
Oh, never mind.
Are you understanding this?
Yeah.
Okay, we good? And the part,
Washington?
remember, this stuff right here, everything inside.
Teachers, please excuse this interruption. If any students have received a red note to take their OAKS test needs to proceed to that computer lab at this time, please. Again, any student receiving the red note for the testing, please report to the computer lab for the OAKS testing. Thank you.
It's for something else. I don't
You did.
Okay. Yep, there's our answer.
And
Okay, questions on that one? We good?
I can't read.
We good?
I was like, you can't read?
Okay, this guy. What about this guy here? Okay, so this is not really a hard question. It's just about kind of interpreting all the math gobbledygook there. What are they trying to say? Okay, if y is defined as f of u and u is defined as g of x,
Yeah.
I do a word.
then they want us to find the derivative of the composition, right? We're gonna do, y is really f of g of x, and so,
This is gonna be cosine,
right,
multiplied
Good.
by the sine, negative sine x.
good. So probably all we wanna do here is just write this as a composition of functions, and then we could just use chain rule, right? So
Yes,
if y equals, if f of x is sine, right, of u, but u is g of x, and that is cosine x, you see that we just have that?
Yes.
We have sine of cosine of x,
Yes.
right?
You multiply by
Okay, is the sine multiplied by the cosine there?
No.
No. Everybody see it's different. It's not a product.
No.
This is a trig function of a trig function.
That is
The
correct.
inside trig function is spitting out values that become the inputs for the outside trig function.
That is
right?
Yes.
Okay, so if we differentiate this then, it's actually not a bad derivative. If we differentiate that at the outermost level, what is it?
Cosine.
Sine.
What's the outside function gonna be? No?
Well, it's sine, but then,
Okay, but you're differentiating, right?
Yeah.
Okay, the outer function is sine of hand, isn't it?
Yeah.
Right, and so if we differentiate sine of hand, that just gives us cosine of hand. So the first layer is cosine of hand. And then the next link would be derivative of cosine, which is,
negative sine x.
Sine.
okay, so we'll just probably put that out front.
No, he-
That's it.
Yep, that's what I get.
Okay, questions? It looks weird, because then you get trig functions and trig functions, but that's okay to do.
Understand it, Kendall?
Uh-huh.
Okay, good.
Questions on that?
No, sir.
Okay.
Dude, I was down at I had no.
How
Yeah,
was
this
it?
is, I think this is kind of a hard one, it's because there's a lot of trig involved too.
Big ass rig too, I was ready to break it.
Dude, it was so much fun.
I couldn't go though.
Take it easy, it's not there.
Just the time.
Okay, stop, stare at that for a second before we jump into it. So if I'm differentiating this, it looks kind of ugly, but don't get intimidated by all the cotangents and cosecants, just follow the rules. At the outermost level, what kind of function is that?
Power.
Power, isn't it?
Power, yeah.
Yeah, good, it's derivative of hand to the negative one.
That's, yep.
So,
Mhm.
so what's the derivative of hand to the negative one?
Negative 1 hand to negative 2.
Negative, good, hand to the negative 2. Okay, and what's the derivative of the inside? What's the next, oops, bad color.
Secant.
So if I look inside, yeah, what's the derivative of cotangent?
Negative cosecant.
Good, negative cosecant squared.
Yeah.
And the derivative of cosecant?
Negative cosecant cotangent.
Negative cosecant cotangent. Plus, and know those. I mean, really, if you don't know those yet, just kind of, I'm gonna force you to, but I just haven't gotten around to it yet. But just, you need to know those. So that's our answer, isn't it? Just a matter of cleaning
Yeah.
that up,
Mhm. Yep.
okay?
That is.
So, let's write this, once again, it's helpful to write it as a big fraction. So if we put the top stuff on top and the bottom stuff on bottom, this stuff goes on top, right, times the negative 1. This stuff, because it's a negative exponent, goes on the bottom, right? So if I distribute this negative through over here, cosecant squared x minus that term, cosecant x, cotangent x, divided by cotangent x minus cosecant x quantity squared. Okay, what about the algebra? It's all algebra, isn't it? There's a lot of algebra, right? Can we simplify the top at all?
You take the
Yeah,
cosecant
you
out.
take
Okay, I
cosecant
could
out,
take a
yeah.
cosecant out, couldn't I? And
Yes, you can.
now let's really be tricky with this. If I take a cosecant out, what am I gonna be left with? Cosecant?
Minus cotangent. So you got
Ah,
the
that almost
negative.
matches the bottom,
You
doesn't
just
it?
take out a negative.
Negative.
Okay, good. So why not instead take out a negative cosecant so we'll get matching factors top and bottom? Does that make sense? Okay, so if I factor out or undistribute that negative cosecant x, I'm gonna be left with a cotangent x minus cosecant x. Good, so then that's coming from,
Oh, I do too.
okay,
Oh,
Yeah.
right?
Yeah.
It's in the bottom.
Everybody see that?
I do.
Okay.
Yes, sir.
Divided by,
Oh, and my
So that cancels
kids.
I can cancel.
Don't forget it's squared on the bottom.
Oh, and it's squared, you're right. Okay, so it's squared, so that's just getting rid of one of those, isn't it?
What'd you say?
So then it's not really crossed out there. I
Okay.
wonder if I can
That's good.
selectively, no, I don't think so. Sorry. I don't think I can't get it. Anyway, that's not crossed out. So we end up then with, use your imagination. Minus cosecant x, and we got one of these guys left on the bottom. That's it. Okay. Make sense?
Yep.
Questions?
Wait, wait.
We did.
But then we put it back in.
Well, no, we did, we factored it out, but if we factor it out from this spot right here, right? If I divide out a negative cosecant, what am I left with? Well, here I'm gonna be left with a negative cosecant. Here I'm gonna be left with a positive cotangent, right? So I just flip them around, so I put the positive one first. There's my negative cosecant. On the bottom, I've got a cotangent x minus cosecant squared, so I have like factors here. Right? I've got this factor to the 1 over this factor to the 2, which leaves me with this factor to the 1 on the bottom. Does that make sense? Questions? Good, okay. Okay, this one, you know, this really isn't very hard, but it's got weird powers of sines and cosines. If you want to, tell me if you want to skip this one.
Let's go ahead and do it.
Okay, it's a quick one, we'll just do it.
Yeah, let's do
Quickie,
it.
quickie.
So, it is chain rule, isn't it? Now,
Yes, it is.
what might not be a bad idea here is to rewrite the sines and the cosines so they look more like chain rule problems. Because remember, this is shorthand. Sine to the negative fifth of x is really equal to what quantity to what power?
Sine x to the-
Sine x to the negative fifth minus cosine x to the sixth. And that makes it look better, doesn't it? Now you can really see the chain rule stuff just popping right
It's
out.
in, Washington.
So if I differentiate at the outermost level, this is two separate terms, right? So I can just differentiate term by term. Right. This guy becomes, that's just hand to the negative fifth. Derivative of that is negative 5 hand to the
Six.
negative sixth. Good, because we're subtracting one. Okay, times the derivative of what's inside. Derivative of sine x is good. Minus derivative of hand to the sixth is 6 hand to the fifth. Derivative of cosine is negative sine. Okay, so what can we do here? Well, we could, this is kind of a little bit of a mess. We've got, if we write these as fractions, a couple ways we can go about this. Let's just take this whole thing right here, and let's write it as a big fraction. So that's negative 5 cosine x on the top
Yes.
over sine to the sixth.
Yep.
Right? But I've got really negative times a negative is plus, right? So plus, on the top we get a 6 sine x. On the bottom we get a cosine to the fifth.
That's positive.
Oh, you're right. Thank you, thank you. So there is nothing on the bottom of that one, is there? Okay, and so, I don't know, they want us to simplify that more or not? I don't have the answer there. I mean, there's not a ton more we can do with that,
No.
really. We could factor out a cosine if we wanted to. I mean, this is about the only thing you really could do reasonably here. Would you agree I've got a only common factor is a cosine?
Mhm.
So if I pull a cosine out, I don't know that that really helps.
No.
If I take a cosine out front, all I'm left with then is negative 5 divided by sine to the sixth. Now what's 1 over sine? Cosecant. C with S, S with C. 1 over sine is cosecant, S with
Oh,
C.
God.
1 over cosine is secant, right?
Let's just give it
Let's just leave it.
And then over here I'm left, I lost one of those, so it's plus 6 sine x cosine to the fourth. But I don't think that really, I mean, honestly, I don't think that really helps that much.
No, it doesn't. I don't like it.
It really doesn't help much at all. So that's probably fine the way it is right there.
Okay.
Right there. Okay. This guy. This is one. This is one I actually want to do. I think people are probably pretty good on this, but these are really important. It's kind of where you have to do, where you're looking at factoring like bases out. This is just trust me, this is an important one.
Okay.
So, outermost level, what do we got?
We had a product.
Is it power, or is it, what do we got in the outermost level?
I see a product.
It's a product, isn't
Come
it?
on.
Right? I've got something times something. I've got an x cubed as my first something. My second something is the quantity 2x minus 3 to the fifth. So I got a product of two things, right?
Yeah.
Two factors. So I got to use product rule. So I get x cubed times, what's the derivative of the second something? Good. Good. Derivative of hand to the fifth is 5 hand to the fourth. Times, derivative of hand would be 2. Okay. Plus, second something, times the derivative of the first something. Good. Derivative of x cubed, just 3x squared. So we're done with the calculus. Right now, it's just a matter of factoring out the like bases, right? Getting this thing simplified. So let's look here now. I've got this thing color-coded in terms of chain rule stuff.
Yeah.
But now let's think about it in terms of like bases. What are the two like bases that you see there? Who's that for?
You.
Oh, for me? All right. Wow, thank you. Fantastic.
Food.
Nice. That's, holy Kaz, would you look at that?
Why don't you get it?
That's like finding $1 in the market, that's great. Okay, so,
Did you really see it?
so what are the like bases? Somebody name a like base. We got these two terms, right? I got a plus sign in the middle. I got a big term in the front and a big term in the back.
2x minus 3.
Okay, so I got a 2x minus 3 is a like base, right? What's another like base? X, yeah. I got an X, don't I? Okay, so now it's just a matter, and remember talking about this, it's a matter of factoring out. If I'm factoring out the greatest common factor, remember what that means? That means it's the smallest common power of the like bases,
Yeah.
right? Okay, so then, what about x cubes? How many x cubes can I take out? I can take out an x squared is all, right? Did I say how many x squared? I meant how many x, what power of x can I take out? X squared, yeah, kind of gave it away. And there's a way you can think about that. This first term could give away up to x cubed, right? But the second one can only give away, it only has 2 powers of x to give away. You can't take more
No.
than the weakest one has to give, right?
Yeah.
So x squared, what's in the other base is 2x minus 3.
More.
Yeah, good, so we can take,
Take 4 of them.
this one has a power of 4 to give away, this one has a power of 5, so we can only take 4 away from both, right?
Yes.
Okay, times, what's left then? So if I take those away
10x.
from the first term, I'm left with, yeah, I get 2 times 5 is 10. So we can cancel those guys. And then this guy's totally gone, isn't it? We divided him away completely.
Yeah, that-
And then we get an
that's
x.
over there.
Good, yeah, we get an x. If we divide away an x squared, we're left with just a single x. Plus, what about this guy? Okay, he's gone, right?
3
So I'm left with a 3, and then I'm left with one of those, right? Good, okay. And so now, these always kind of work out to be the same. We're gonna get these are done, right? We factored out the greatest common factors, right? What what's left behind, this big leftover factor, we just have to clean up, and that becomes the third factor, right? So we end up with, all of this becomes, what, if I distribute it, get 10x plus 6x,
16x minus 5.
there we go, times this stuff, right? And so probably the way, if we're gonna be really, mathematical, and mathematicians are so anal about this stuff, if we were to write this out in mathematician-friendly format, it probably would just be something like 16x minus 9 times x squared times the quantity 2x minus 3 to the fourth, but it doesn't matter. Okay. As long as we get it factored. Questions?
Not.
Okay. Good. All right. Here's this one. Really, the only thing I wanted to point out on this one, this isn't a big deal. The
No.
only thing I wanted to point out here is, look at that and tell me, how many layers are there to that function? How many links in the chain should we expect?
3.
3. Seeing 3.
Two out.
I
Yeah.
see
And
3.
it helps.
Nice job, Brian.
It helps to write the 2 outside of the quantity, right? So we could write
Dude, I'm
this
feeling
as
Feeling
There's
it.
two or three.
Dude, I've been ready for that test today.
This is what we could do. This is this past 3.
now you can see it's 3.
The red side.
Right. I've got a power.
Let's see.
Inside the power, I've got a sign. Inside the sign, I've just got this little polynomial.
I see.
Okay. So I'm gonna get 3 links to that chain when I differentiate. Okay.
Oh, that's not that hard.
Yeah, and how about this one? How do I deal with this one?
Just the 1/2.
Good.
Yeah.
Rewrite the square root, go ahead.
He shows the last
Oh, yeah, we can go through it, sure.
Oh,
Okay, so,
just kidding, you're good.
so, y prime, so let's look at this layer by layer. So the first link is gonna be, well, that's just the power, right? I've just got hand squared for the first link. So 2 times hand to the 1. Okay, next link. Okay, we take away the 2, now I've got sine, derivative, sine hand, cosine hand. Good. Times, if I look inside that, right now I'm just looking at that stuff right there, the derivative of 7 pi t minus 3. We're differentiating with
7
respect
pi.
to t. Yeah, so that's just 7 pi. Everybody see that?
Yes. Totally.
Did that last layer make sense, that 7 pi?
What I was trying to like find sure.
And so if I were to simplify this, I could pull that, that's just a constant, I could pull that out front. 14 pi sine times cosine.
Yep. Kill him.
Right?
Mm-hmm.
And if we were gonna be really tricky with this, which we wouldn't necessarily do, here's the way we could make this 7 pi times the sine of 2 times. Right? See that one? Because if this is a theta, you don't have to do this, but if that's a theta and that's a theta, we know that 2 sine theta cosine theta equals sine of 2 theta, right? Right? See that? So we could borrow a 2 from the 14, right? 2 sine theta cosine theta, that would become, all that stuff just becomes a sine of 2 theta. That's pretty tricky,
Yeah.
right?
Not feeling it.
Okay. Hang on. Yeah, please.
I bet your dad was so happy.
I'm leaving the house. I left.
Okay, we good?
I was like, your game is over now.
Okay, so this one,
He was. I was so
oh,
weird.
here we go. So this one, you tell me if you wanna do it or not. I mean, this really, if we rewrite this, the trick,
I got it.
not really the trick, but the hint here is to take the radical and rewrite it as power. So we get the quantity A,
Sine of A.
it's not really A, I guess that's really an alpha.
Oh. One.
No, it's not a fish, it's an alpha. Okay,
You didn't see it before.
sign of fish, sign fish.
What's the derivative of scale?
Okay, so here we go, how many layers on this one?
No. You have to have a
No.
product.
Okay.
Product. Oh my god.
There's a product
so there's-
in there too.
There's really two, right? I've got a power, but then inside the power, I've got a product. So the second link is kind of a nasty one, it's a big one.
Yeah. So,
Product.
Excellent.
Do we wanna see this or not?
Yes.
Okay?
fish sine fish. I like that.
What is this?
Okay, so what's first layer? First link.
One half.
One half.
Fish sine fish.
What power?
Negative one.
Negative one half.
Well, negative 1/2, right? 'Cause we're subtracting, right? Okay, times fish sine fish.
Yes. See, he's got it too. I'm really enjoying fish calculus. I like fish.
Okay, now, next layer.
Oh, God.
If we look inside, if we differentiate this product, what's that gonna look like?
Fish.
Fish,
Cosine fish.
cosine fish.
Plus.
Plus. Sine fish.
Sine fish times. Yeah.
Sine fish,
Yeah.
right?
Yeah.
Yeah, is it? Okay,
No,
And-
I like fish.
that's it. That's it. All we would do here, though, if we wanted to clean this up a little bit,
Put that on the bottom. We got half.
just put the bottom stuff on the bottom. Okay, what constant ends up on the bottom?
2.
2, because we got a 2
And one half.
right there. So 2,
Sine.
Fish sine fish.
okay, does everybody see that?
Yep.
Yeah.
A negative 1/2 power is just a 1/2 on the bottom, and we could write that as a square root if we wanted.
Yes, we
Okay,
can.
and then on the top, we just get this stuff.
Yes, we could.
Right? We good?
Yes, we are. Yeah, very good.
Okay, this is a bad one.
Double
This is-
prime.
This is a good one to end up on,
Okay, well.
if we can make it, we'll try.
Double prime. Just keep the 4 in front.
Yes, good.
Killer. Dude,
Okay, leave that 4 out front. Now, if we're trying to find the second derivative here, that's what makes this one a little bit nasty.
What's the first one first?
So, what's y prime?
Uh.
Or secant x tangent x?
Yeah.
Good, secant x, tangent.
Good job.
It's not that nasty after all, is it? It's not terrible.
No
But
fish.
taking the second derivative, it gets worse because we got a product.
God, I hate product rule.
Push it through first.
Yeah, but I don't mind quotient rule.
Okay, so, up here please. We got finished strong and we got a long break. So we got secant x first times derivative of the second. What's the derivative of tangent?
Secant square x.
Okay, good, plus,
Tangent x, secant.
Secant x tangent x.
oops,
Okay, we're just going.
gotta get my colors.
Y double prime equals 4.
Okay, good. So look what we got here. Would you agree that I could factor out a secant x from both of those?
Yep.
Okay, so I'm gonna get, and what am I left with then? Well, secant squared x plus tangent squared x. Now remember,
That's.
that's something, isn't it?
There is something.
That's something. Okay, I think that's something. Yeah, that is something. We can do something with that. Not a ton. But if I never remember this, you'll probably never remember, but it's really easy to derive these other trig identities from the main Pythagorean trig identity. If you can just remember, I think I've showed this to you before, probably a million times. Sine squared x plus cosine squared x equals 1. If you can do that one, then if I want to get secants and tangents, I would divide both sides through by cosine squared, right?
Yeah.
Everybody agree?
Yes.
So if I do that, what's that give us on this side?
Big bunch. That's gonna be.
Tangent squared x plus 1 equals
Oh,
secant squared x, right?
negative.
Okay, so not quite. All we can do here, though, all we can do with this that's nice, and this is the last, then this will be a good place to end. Look at, we have two different kinds of trig functions here. It would be nice if we could write this in terms of a single trig function, which we can do. If I were to solve for tangent squared in terms of secants, I could make that substitution, right? Everybody see that?
Yeah.
So I could just subtract 1 from both sides and get the substitution equation.
Killer.
See?
Oh,
See?
Oh, yes.
Oh.
So plug that in up there,
Oh, yes.
okay? Right? And so this tangent squared,
It's just gonna be secant squared x minus 1, which then equals.
so I'm gonna get secant squared plus secant squared, 2 secant squared minus 1,
Yeah.
beside this factor.
Unnecessary stuff.
Okay? That's where we'll pick it up. Well, no, that's pretty useful. That's gonna be, that'll be useful too. All right, have a wonderful vacation. I will put the other practice test up if you want to get a jump on those. Okay? But we'll continue this on Monday after break.